Dr. Leonor Terrason, is that correctly pronounced? Good. A research director and scientific expert from NILU, and that stands for Norwegian Institute for Air Research. And as far as I know, the air is very nice up in Norway, quite a bit cleaner maybe even than here in Copenhagen at least. And Leonor Terrason holds a doctorate in meteorology and atmospheric chemistry. She has 30 years experience on air pollution, supporting the implementation of control options and air quality legislation at urban and European level. She will inspire you for the next 15 minutes. Please give a big round of applause to Leonor.
It's a pleasure to be here. So thank you for this possibility of coming with different mindsets. It's been very interesting in the morning to hear things from different angles. And it's a bit what I'm trying to do now, because it's very inspiring to hear Professor Fujishima talking about the innovation in Japan and how this innovation has following also what Carlos had here. In Europe, we think a lot about effects, protection of human health, protection of ecosystems. And then we are looking at the problem of air pollution, which is one of the applications that you've been mentioning. And the first thing when we hear about air pollution is not necessarily Norway we're related to, but Beijing, for instance, that's a place that we know it is much worse than it is in Tokyo. It's one of the worst places in most cities in the world for the part of air quality. And what I wanted to show is that the World Health Organization, and I'm sure you all have heard about that, has declared, in fact, air pollution as a very important health hazard, with 7 million deaths a year. And this has been done since 2014. We are getting new reports every year. The values are about the same, with about half of it, 3.7 million deaths are from outside air, and then the indoor air is also very important, which is the 4.3 million. So it's important when we think of materials and what Photocad is doing, that it's also indoors that we are affected with air pollution. But today I will talk much more on the part of the outdoor air and what the problems are. If we think of air pollution now, it's the third cause of deaths. The first one is overeating, obesity problems. We have the high blood pressure as number 2. And then air pollution is together with tobacco. So think about it. We are really getting to a level of exposures now that globally are making our health very, very limited, or producing both deaths and limitation of lifetime. What are the main pollutants we are focusing in? And this is a part that the values that you've been reading about, it's not all the ingredients in the air. It's mostly the ones we know, the ones that we've been working with for a long time, and the ones that are regulated. In Europe, we have regulation for the urban air, mostly on particulate matter and nitrogen oxides. Particulate matter has 2 different components. It is what we call the particulate matter with diameters smaller than 2.5 micrometers, and the ones that are with diameters smaller than 10 micrometers. And we write it like this: particulate matter 10 and particulate matter 2.5. These are the different type of particles. We also have ultrafines that are affecting air quality. Those particulates come from many different sources. They come from traffic, they come from road friction, especially the coarse particles, the larger ones. When we work, when we are in our cars and we are driving with the wheels, the friction is creating a suspension that really comes back. It's the asphalt, it's the deck, it's the brakes. All this is all that part comes in. We breathe it, and it also goes as part, especially important for microplastics in the oceans. That's all the parts that relate. It's not only air pollution, but it relates to what happens also in other parts of the environment. Particulate matter comes a lot from domestic heating, and here in the north of Europe we have wood burning as a favorite heating system, and it's creating a lot of problems. And it's really one of the reasons why we have more of this particulate matter. Construction sites. It's also another part that we need to think about that are important parts. Waste and industrial processes also affect this. And then the control options that we have for that. Usually we use that principle, that we go to the sources. We don't do something else to compensate, but let's try to reduce it from the source itself. So most of the actions that we are taking for particulate matter are very complex because they have to address many different sources. The message I wanted to give you is that for nitrogen oxides, it's quite simple. They come from exhaust from the traffic. It is whatever the cars, they come from cars, they come from trucks, from buses. It is traffic and exhaust from the pipes of this traffic that creates the pollution of the nitrogen oxides. Which means that our control options usually go either to reduce the volume, saying people do not travel so much or travel in alternative ways, or technology changes, and I will talk a bit more about that in the next part. So in Europe, when I've been showing when it was in other parts of the world, we know it's worse, but how is it in Europe? This is the air quality index from the European Environment Agency that is here in Copenhagen. And they have redeveloped now from all the systems, the monitoring systems that we have, the regulatory systems that we have in Europe. They compile all this data and give an index based on particulate matter, ozone, NO2, so it's a combination. And what you see today, this is the situation today, and it is quite nice, in fact. The muscle is working, no, it didn't work the way I wanted, so. Here. What I wanted to show is, well, here in Copenhagen and in the northern or the southern part of Norway, it's not too bad with the air, but you see some problems in northern cities, and you see some problems in southern Europe. In northern Europe, the problems are usually now, because it is the time the spring comes, and then we have the roads full with sand and with grass, with small stones, because the ice now is leaving out. In the spring, you always have problems with the air pollution in those areas, because it's when the cars are moving, you get all the dust, and it's what we call resuspension. That doesn't happen in southern Spain. There, and in some of the southern European cities that you see there is today Saharan dust. It comes, and that's the reason why you have it there. While in Eastern Europe, what we are having is a PM episode, that it is mostly because of domestic heating, that it is the wood consumption in those areas. So what you see is very different research for that in particulate matter. But when we look at nitrogen dioxide, it is, even in Norway, where we have very clean air, we have incidences in most cities. In Oslo, in Bergen, in Trondheim, over the years, we've always gone above the limits that are given by European legislation. One thing that is important to know, the worst situation with NO2, it's always in winter. It is in the conditions of very clear skies, when we have what we call inversions, that then the air gets trapped, and you can get a situation where an anticyclone comes, you have the good weather, and then traps the air in the city. You have ice in the surface, and you have a situation where the circulation keeps being like a cooking pot that then gets your levels of NO2 very high. So usually you have this during the winter time, and that's important because it is the time where we have NO2 with the lowest also insolation. We have very little solar light, and NO2 doesn't photooxidize to become ozone. In the summertime, it's not a problem because NO2 oxidizes, we get ozone instead. And that is not really a problem in the middle of the summertime. But in the winter is when we get these type of situations. So if we think of buildings and coatings, we have to think that we want to have them also working, especially if we're thinking of pavements. Think about it covered with the snow, it will not have the same effect. And it is, at that time, we need them. So we need to put these coatings on the buildings and not always on the floors. But we'll get to that. What I wanted to show to you also is how the activities in Oslo, what are the reasons for NO2 pollution? And what we see is that Oslo was during a time very much concerned with climate pollution. And thinking of climate change, we decided that diesel cars were very good because of the fuel efficiency, and they have very low CO2 emissions. So diesel cars were put with a benefit in 2007, so that people could buy those that were climate friendly type of cars. So we had a vehicle fleet that had 75% of all new cars that were bought in 2014 already. From 2007 to 14, it was 75% were diesel. But the situation changed dramatically in 2014, where we began saying the NO2 problem. It's very well illustrated here. When you go into the city, driving, when you put your cars that you have from the tests in laboratories that show you that they are complying with legislation, then you put them into the real condition. And real conditions means police parts, maybe working with situations where temperatures are very low. You're having other types of working in that makes a difference between a car on the model of 2012, a diesel car, or a car in petrol has enormous differences in the emissions of energy. So Norway began working with this changing towards electric cars and better a modification of the vehicle fleet that then allowed more green cars. And now we have 20% of all the cars bought in Norway is 20% are electric. So we have a very large increase of that, and the diesel car is going down, so it's either electric or petrol. Something that I think it's important to think about, because this is another example when I talked about diesel cars being with incentives and being promoted because of the climate change situation, is because we didn't think of climate change and air pollution. We didn't put those effects together. Some other times happens that a technology comes in and we have regulations, but it doesn't work the way we intended. In the case of NOx emissions, if you see the values, the Euro standards is the way our regulation is made, so that the cars that are produced for different years have a standard of green mobility. Those standards from Euro 1 to Euro 6, you can see that the NOx, even if you're driving in a queue or in the city or in local roads, which is the different curves that you see here, you see it goes down. This is what we intended. This is what the legislation wanted to have. Then it was introduced with a catalyst inside the cars. That what made it was that it changed the value between NO and NO2. NOx is the combination of those two, the nitrogen monoxide and nitrogen dioxide. And what happened is, because of the catalytic, and it came in fact in Euro 3, it came in 2000. It is something that we didn't have before, but when this technology came in, the levels of NO2 were getting larger, and it happened over the whole of Europe. And this is why it is interesting, that now with Euro 6 we see that it will go down again, so we believe that this situation will be curbed. We also believe there was a time when I was working on this that I thought in 2010 problems are solved. But the fact is that when you put it into the real conditions, you don't see this. It has not happened. We understand why. It is the NO2 NO balance. We know what it comes from. We know also that there's been Dieselgate and that sometimes we cheat on the results. One thing is what you do in a laboratory, another thing is what you do in the car. But what it is very good is that we have monitoring systems and that we have the consciousness that, all right, this is technology, this is good, let's look at it and let's look at the effects. We know the effects and that has been identified. That means we have other options to work with. And these are the control measures that we've been working with for NO2. The green mobility options, we know that technologies, it's good, we have to work with that. We have this electric yet, the trolleys in the city. We also have cars now. The buses in Oslo, they are going to be electric. They've been trying during a while for biofuels, they've been trying different options, and this is interesting to see that you put some measures there to promote greener mobility in the cities. The background, of course, is cycling, that's interesting, it's activity, it's a much better way to think about it. But when you have to look at technologies that can help. We also work very intensively on the establishment of low emission zones, and we do that depending where the people live, what is the mobility part. So each city, depending on the conditions of pollution that we have and traffic, you decide where to put your low emission zone with tolls and incentives, so that you reduce the mobility and you reduce the emissions, but not the mobility of the people. Collective transport is important, and the communication is important, but what we are looking for the end pollution part is how we need to curb this NO2 problem with reducing the sources of the environment. There is an additional way, and I showed you that 90% of the emissions in Oslo of NO2 come from traffic, but it can be also things that come from other cities. How do you protect your city? And it can be things like these benign by design options, these alternative measures of putting these photocatalytic materials in urban environments. I think that's very interesting. It has been used in laboratories. The point that is important to make is this winter situation, that then if we have the pavement covered by ice and snow, maybe the effects will not be the same. And that's a bit what we are seeing. In the laboratories it's working all right. Systematically tested in the real world is still not there. And we need to think on how are we going to do this? What happens with the snow and ice? What happens when you have low insulation situations, when you don't have the conditions for getting the photolytical process to function the same way as it needs to be done? What happens with unwanted effects? This is really a very highly oxidizing capability that you have there. There are a lot of other VOCs in the city. What happens if you are oxidizing other things and you are producing other things that you didn't expect were there? I'm thinking formaldehyde, for instance, it can be there. But these effects, we can only know them when we use it. And what it's important is that we don't stop this innovation by saying it's gone, that's it, deal with the effects. And what is important maybe is to make sure that when those materials get into the cities, which is very interesting to see it's happening, that we really make sure that we evaluate how effective they are. That we make sure that we have the same as we had for the case of the Dieselgate, that we could measure and we could see this is not what we are expecting, that we can measure, that we can go out and measure, is this effective, really what it has to be? Do we have the right testing put into place? And that includes citizen science, because for NO2, people can really begin measuring themselves, but it includes also sophisticated laboratories and use of the regulatory air quality monitoring. So this is the message that I wanted to give to you. Important to go important that we have the NO2 pollution addressed with green mobility. That's the main cause. Let's go to the causes and control with the emission sources. But additional measures can be very interesting, can have different effects. Let's look at the health effects and the effects that it can have in the city through makes our innovation sustainable for the long term. So thank you very much for your attention.